Problem 2.4 in KLEIN's second edition organic chemistry shows us this cyclopropane, this molecule here, and it has only one other constitutional isomer that you can make for it, and they ask you to draw a condensed structure of that isomer. So basically, there's many different ways to think about solving this problem. You can draw out the Lewis structure for this, and you can see that, you know, it has a total of 3 carbons and 6 hydrogens. So that's what you have to play with. Now, there's no real other way to make a ring structure of this, so you could try breaking it apart. And you might think, well, another structure might be, this, right? But if you try to draw a Lewis structure, again, Lewis structures are very important to recognize and to check things when you're first starting out as an organic chemistry student, because if you draw now the Lewis structure for this, you'll see that there's a problem. These 2 carbons on the end only have 3 bonds to it, right? They are not tetravalent. Carbon always likes to have 4 bonds. So we need to think about, what could we possibly do? If you just work off the formula here, okay, and you just try to draw an isomer for this, you have, 3 carbons and 6 hydrogens. So let's try to put in some hydrogens. 1, 2, 3, 4, maybe 5, 6. Okay, and guess what? What we're doing here is we're positioning the 2 carbons with only 3 bonds next to each other. And what we want to do now is satisfy the tetravalency requirement of carbon by putting a double bond between those 2 carbons. Now, if you do that, boom, magically everything comes together. And once you see the answer, it's obvious, but the process here is important. Try to put those angry atoms next to each other, make additional bonding, and then oftentimes you can satisfy the formula. Now, this is not a condensed structure. It's a typo there. This is not a condensed structure. This is a Lewis structure. So let's take this condensed structure now and make a Lewis structure. On the left, we have a carbon with 3 hydrogens. In the middle, we have a CH. And then on the right, we have a CH2. It's customary to draw that double bond. And let's draw a CH2. Okay? So that's the final answer right here. Okay? Thanks for watching.